Hello, guys. My name is Desmond.
Evening.
And I welcome you to my lesson for today, where we'll be looking at your mathematics. So, ladies and gentlemen, obviously, since the beginning of this week, we've been looking at mathematics, specifically your functions. So in today's lesson, what I'm hoping to do, ladies and gentlemen, is to quickly go through the last part or the last type of a function that we did last week Friday. But it's unfortunate, I think towards the end of our lesson, the network was a bit poor. So what I'm actually going to be doing in today's lesson is to finish off that exponential graph, and then from there do a very quick revision of straight line, parabola, and hyperbola, so that starting from tomorrow, ladies and gentlemen, straight away we solve exam type of questions. So we started with straight line last week, Monday. On Tuesday, we looked at parabola. And then on Wednesday, we looked at hyperbola. And then I think it was on Thursday or Friday, we did look at exponential. It's unfortunate it was the end of our lesson. Due to load shedding, the network got poor and we couldn't do everything. So now, for today's lesson, ladies and gentlemen, let's have a look at exponential. We'll discuss all that you need to be aware of regarding exponential. Once we are done, then as indicated, I'm going to quickly take you through straight line, parabola, and hyperbola. Exponential. A very warm welcome to our new learners. I notice Kenzani Given is on the line. I'm just not sure about Oratile, but guys, thanks very much for joining, and I hope you will enjoy my lesson for today. Hey, ladies and gentlemen, please do allow me to say it is very much important, Lebohan, that I say it is very, very much important, Shravan, because what I'm about to say, Mr. Given, it is massively, 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 hey, massively important, ladies and gentlemen, that I say a day without learning something new. Tapang, it's a day wasted. Please, Shravan, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, with regards to exponential graph of exponential function, remember, guys, we said we looked at it from a baby stage, and then we looked at it at a teenage stage, and then from there we looked at it at an adult stage. So I'm going to explain each of these stages, ladies and gentlemen. So just make sure that you listen very carefully. No need to be writing everything that I'm writing down, Evangeline. The reason to that is because we've got a library where we post all of our notes, the tutor's notes, question papers, and memos of all the high school subjects. That includes counting, life sciences, physical sciences, mathematics, math lit, all high school subjects. We post question papers and the memos there together with the notes and some study guides. So for you in today's lesson is just to pay attention to all that I'll be talking about. So remember, guys, we are now dealing with an exponential type of a function. Remember, this is where it started. At a baby stage, it started as y being equals to b to the exponent of x. I'm telling you, evangelist, whoever who discovered this type of a function being exponential, they started it as something similar to that. Obviously, as a human being, as a baby, over time you grow, you evolve, and everything. So now, when we look at an exponential type of a function at a teenage stage, this is how it looks like. It looks like y being equals to, now we are having a multiplying that b to the exponent of x. Can you see? The only difference when you compare the two is that now we are having a multiplying the whole of that. So as we continue with our lesson for today, I'm going to be explaining to you the impact of that b on your exponential function, and again the impact of that a value on that exponential function. And most importantly, ladies and gentlemen, obviously, as you grow from teenage stage, you are now entering into an adult stage. And at an adult stage, this is how the function normally looks like. It's y being equals to, you are having a multiplied by b to the exponent that, and then we've got plus c over there. Can you see? This is the initial stage. Over time, they discovered that we can introduce a value over there, and then now you can see there's an addition of c over there. So now let's try, ladies and gentlemen, let's try to actually discuss all the important stuff that you need to be aware of regarding an exponential. Remember, guys, remember, I did make some notes on Friday's lesson to say when b value it is greater than 1, y values increase. And if you remember, we said we therefore have an increasing function, which means, good people, when this b value, remember the b value, always when I talk about b, I'm referring to that value. So when this b value is actually between 0 and 1, y values decrease. Remember, ladies and gentlemen, everything that I explain here, Kensani, it has to make sense, and not necessarily by fire, by force, but it just has to make sense. I do not just write that and not explain to you, Mr. Ragunanen. So now I'm about to explain what do I mean by when b is greater than that, whatever by that, when is whatever over there. So let's see. Remember, a b value being greater than 1, it could be any number from 1.1, 1.2, 1.5, 1 point whatever, up to 2, 3, 7, 10, 1,000, a million, whatever. These are the values, greater than 1. Maybe let me say, these are the values greater than 1. And again, when we talk about values which are between 0 and 1, we can talk about 0,1, 0,2, 0,5, 0,9, or 1. No, it can never be 1. Maybe 0,97. What can you see? From 0,1 up to 0,9, these are the values which are between 0 and 1. But examiner won't necessarily have to say for example, 0.5 to the exponent of x, but they are most likely to give it to you in a form of a fraction and to say maybe y it is equals to a half to the power of that. Then you know this is an exponential type of a function. But when you punch this on a calculator and try to convert it to a decimal, you therefore get 0.5, and 0.5 is a value which is between 0 and 1. What do we have when we have b value being between that and that? The y values decrease. So what I've explained just now, Lerato, is just what it's meant by values greater than 1 and values between 0 and 1. So when we say when b is greater than 1, y values increase, it simply means on your Cartesian plane, Oratile, what is a Cartesian plane? A Cartesian plane is this horizontal axis called x and a vertical line called y. So remember, you can either have an exponential type of a function drawn like that or drawn like that. Notice something. You always start from the left going in that direction. That's when it is going to make sense when we say a function has got y increasing or decreasing. So let's maybe draw one where b is greater than 1, meaning the y values increase. It is this one. Remember, there it is 0, then we have maybe 1 or 2, 4, 6, 8, 10, 12, whatever. So now, can you guys see that as I do this, the y value is increasing? Can you guys see the y value is increasing? Very, very much important over there. So that means in this case, this is where you might be having y it is equals to. I'll give an example as 2 to the exponent of x. So can you now see that the b value it is actually greater than 1? Again, it could be y it is equals to 3 over 2 to the exponent of x. Is 3 over 2 greater than 1? I think if you punch that on a calculator, it is going to give you 1.5. Therefore, it suits to be that type of a function, or the shape will be that one. So obviously there, it could be 1. This is 0.5, 1.4, whatever. It doesn't really matter that much. I just wanted to explain to you that when you have a b value greater than 1, you have y values increasing. So it's more like we are having that type of a shape. But when you have the b value between 0 and 1, so there you could be having, let's say, y into something like 2 over 5 as an example to the exponent of that. So there, can you see what happens to the y values? Can you see the y values are decreasing, decreasing, keeps on decreasing up to infinity. But remember, we said this function, it actually runs closer, or it continues to get closer to this line. It never touches, it never crosses that line. Why? Because inside this x-axis, we've got what we call what is it? An asymptote, guys. You remember we spoke about the asymptotes when we were doing a hyperbola, and I said on a hyperbola, you've got 2 asymptotes. But when it comes to an exponential, you've got 1 asymptote. What is asymptote? Asymptote is an asymptote, guys. Uh, guys, I'm back. I noticed there was a bit of a disconnection. I'm not sure if all of you guys can still be able to see me. No, not me, but over there. Can you guys be able to see there?
So I can see the board, sir.
Last one to confirm. Are you guys saying all is in order on your side?
Yes, I can see the board and I can hear you.
100%. So what I was saying, Shravan, is to say when we're dealing with an exponential type of a function, we've got an asymptote which is inside the x axis over there. So now what I was explaining over there is to say when you've got the b value being between 0 and 1, you've got a function in that direction. So can you see, as we move in that direction, the y values decrease for this one. But for that one, you can see the y values are increasing. Those are the difference between the two. So again, let's discuss something very much important over there. Maybe let me not remove that, but use a different marking pen. So everything that I discussed regarding those two, it was actually the b value. So now that you understand what is the impact of b on the exponential function, let's have a look at the impact of a value. So the impact of a value, it is actually nothing else but the steepness of the function. I just don't have a space to write over there, but let me just say the a value actually has an influence or an impact on the steepness. So what exactly are we talking about when we talk about the steepness? Let's maybe think about Leratos Mountain. How would Leratos Mountain look like? Let's say, for example, we've got that type of a mountain over there. Can you see? When you look at this Leratos Mountain versus Gavin's Mountain, maybe this is Gavin's Mountain, which looks almost like Table Mountains. So this is Gavin's Mountain. So can you guys see that this function, it is not that much steep when you compare it with that mountain. So that is what we mean by the steepness of a mountain. So assuming that this is Leratos mountain, maybe if we increase the a value, then the steepness will increase. We end up having Kevin's mountain. It could possibly be something similar to that. Can you guys see the difference between the two? So that means for this, we've got obviously invisible 1 over there multiplying 2 to the exponent x. But for this one, that means we might be having y is equals to, it could be 3 times 2 to the exponent of x. Very, very much important, ladies and gentlemen, over there. So that means the a value influences the steepness. The bigger the a value, the bigger or the steep or the slope of your function. So maybe for a function of y being equals to, let's say, half times 2 to the exponent x over there, you might find that because of this is now a half, or it's a lesser value compared to 3, you might find that maybe your function, it is now something like that. Why? Because the steepness or the a value is smaller or is lower, therefore even the slope it's not that steep, but it is just almost smooth or gradually increased. Guys, did I not lose you when I was explaining the A and the B value before I move to the C value there? Are we still on the same page, guys, or is there someone who'd like to ask a question there? Guys, Sepang, ra utlwana foo.
Yeah,
Lerato,
understood.
Kensan, bayasitwisisa ngangeni. Let me see. Shravan. Lebza.
Sir, I understand.
Okay. 100%. Also, let me not remove this drawing, but instead, what I want to quickly do, it is actually to explain the C value. So, the C value, ladies and gentlemen, it tells us more about the vertical shift. So they might use Q there, they might use P or any letter from A up to Z. It doesn't really matter that much in terms of which letter they use, but you just need to be aware that whichever letter that they use, it's going to be any letter from A all the way up to Z. But in this case, I chose to use letter C. And normally they use letter C because C, it actually represents, or it stands for constant. And what does constant mean to us in maths? It simply means just a number, which could be a negative number, a -1, -2, or +1, +2, or whatever number, ladies and gentlemen. So now, what do we mean by vertical shift? Remember, vertical shift means something can shift up or down. That's what a vertical shift means. Something can shift up or down. If something shifts upwards, we are going to have a positive C value. If it shifts downwards, we are going to have a negative C value. So now, let's say, for example, we still have that function of y being equals to 2 to the exponent x. Maybe there you've got positive 2. So what does that 2 mean? It actually means this function shifted by 2 units upwards. So if this is the function and it was actually touching the y value there at 1, so it's more like we shift it as it is by 1, 2 units. So that means it retains the same shape, the same steepness, the same everything. It's only that it is no longer passing through 1 there, but it is passing through that point. What is it? 1, 2. Obviously, there's 1, then 2, 3. Then it means it is now cutting the y-axis at 3 over there. So now, remember, guys, I said there's always that asymptote on this type of a function. So also that asymptote, it actually shifts by 2 units upwards. So I might need to redraw that nicely. So that means before you can draw that shape of a function, let's firstly draw what is it? That asymptote. So from 0, it shifts by 1, 2. So that means now it is no longer within the x-axis, but it has also shifted upwards, which means your function also, it is just going to run closer or work towards getting closer to that line, but it never touch, it never cross, nothing of that nature. I'm not sure. Anyone who's got a question, guys, on what I've just explained over there, because I think I've actually said all that I wanted you guys to be aware of. What I'm then going to do is just to quickly try to do one sketch, and then we'll leave it from there. Some more stuff we'll discover those as we do exam type of question papers. But anyone who's got a question, ladies and gentlemen.
Sir. Sir.
Mr. Given, is it given or oh yes, given?
Okay, sir. So there was a little bit off because there was load shedding.
Oh, you mean
So
just now during this
I
lesson?
did not catch that part whereby you said
Given, I think your
yes.
line is breaking, but I only got when you said you got a disturbance as a result of load shedding. Just
So like I did not catch that part whereby you're saying that it shifts up or down.
okay.
I see that you put the plus and minus C.
Okay. I will just re-explain that one, Kevin. I just noticed your audio is breaking that side. So in the meantime, you can just mute your mic, Kevin. Given.
Okay,
So
sir.
I will quickly
See
try
where
to
you
re-explain that
have
part. I noticed
contact your
Given is still
marker
explaining again,
whereby you
but let me just mute him from my side. So Given, what I was about to say is that I did get your question. From what I understand, you couldn't get the part where I was explaining the vertical shift, which is something that I'm going to quickly explain just now. So I was saying that, see over there, it actually tells us about the vertical shift. So I'll just write it down over there to say C value tells us about the vertical shift. So the vertical shift, when we say something shifts vertically, it's either it shifts up or down. So now positive sign means up, and then now negative sign means down. So that means if we have a function of y, it's equals to, let's say, 2 to the exponent x, maybe minus 4. So that means this function has actually shifted by 4 units downwards. If it's positive 2, for example, it means that function has actually shifted 2 units upwards. So obviously the original function, which is that one, it was cutting the y-axis there at 1. But because of that 2, then it means it shifted by 1, 2 upwards. That is why we say when it shifts, it also shifts with that asymptote. So the first thing that you need to do is to draw an asymptote, which is that one over there. Therefore, you can then draw that same function with the same slope over there. So I'm just going to quickly make sure that I draw a function over there so that you can see what I mean by all that I'm explaining over there. But before I do that, I just wanted to check, Is there someone who's got a question there? I hope given is answered there. But did you all understand all that I've explained over there?
Yes, sir.
Yes, sir.
Okay, 100%. So now, what I'm going to do, maybe let me not remove all of this. Let me not erase all of this. But what I'm going to do is just to bring this and use this board to explain. Let's see. Okay, so now let's say we sketch the function of y is equals to let's say 2 to the exponent of x over there. So let's see, obviously we can say where x it is maybe -3, -2, -1, 0, 1, 2, 3. We want to see what is the corresponding y value. Then we're going to sketch that on a Cartesian plane. So guys, on your calculator, remember, if you don't have a calculator, you can pull out your calculator. I'm not sure, given if your parents bought you a calculator or a calculator, but you can see over there, I've got my calculator. Let's punch. So, where y is -3, I want to know what is the corresponding y value. So you're going to say 2 to the exponent of -3. So can you see the y value? It is actually 0,125. Let's say maybe it's 0,1. I'm going to edit there and put -3. Just make sure that if I'm doing wrong calculations, you correct me there. So this one I'll round it off. It's 0,3. And then when it's -1, I'm having 0,5 there. And then when it's 0, I know I'm going to get 1. And then when it's 1, I'm getting 2. And then I know when it's 2, I'm going to get 4. Yes, 2 squared is 4. When it's 3, I think I'm going to get 8. Is this correct, guys? Is that correct? Ek denk so. If you guys were punching all of that on your calculators, I think you are also going to get the same thing. So now, remember, guys, the first thing that you start with, it's actually an equation of your asymptote. So can you see there? This is more like it's actually plus 0 there. So your asymptote, it is actually 0. So that means it is within the x-axis. You have your asymptote within the x-axis. If, for example, there, let's say it was 2, that means it was going to be a 2. If there it was 3, it was going to be at 3. If there was 5, at 5. If it was 7, at 7. If it was -2, you do it on this side on -2. If it's nothing there, then it means it's 0. Does it make sense, Ravan? Do you get that part? Tsepang. No, Tsepang just joined. Lerato. Uyayithola le ndaba le. Shreyas,
Yes.
do you get it?
Yes, sir.
Okay, 100%. So now we've got our asymptote within the x-axis. So let's now plot where x is -3. Let me just do all of that and see. Maybe we've got a -1 there, -2, -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, or whatever there. Maybe I can squeeze in something there. Let me have something there and there. Okay, so now where x is -3, this is y. Maybe we can see something somewhere there. No, somewhere down there. No, let me actually use this ink. So it is actually, let's say there. Where x is -2, y it's let's say 0,3, somewhere there. Where x is -1, it is where y it is half. Where x is 0, y is 1, which is that point there. Where x is 1, this is 2, 1, and then that is 2 there. Where this is 2, that is 4, 2, 1, 2, 3, 4. Maybe let's say something somewhere there. Where that is 3, this is 8. 1, 2, 3, 4, 5, 6, 7, 8. 8, maybe something somewhere there. So can you guys see that it is just a matter of you joining, you are connecting the dots, forming that shape of an exponential, and then it continues, then it continues. So this is the function of y, it is equals to 2 to the exponent of x. Let's say, for example, now they want us to sketch y, it is equals to the same thing, 2 to the exponent that, but this is now, let's say, plus 1. So when it's plus 1, it's more like the whole thing, it now shifts upwards by 1 unit. So can you guys now see that this is now your new asymptote? Then you firstly start with it at where y it is equals to 1 over there. Therefore, obviously, if everything shifts upwards, it therefore means it is now going to cut there where this is 2, where y it is 2. Therefore, this function is that one of y is equals to 2 to the exponent that but plus 1. Then if, for example, we sketch another one of maybe, let's say, plus 4, then it's more like this thing, that original one of 2 to the exponent x, we just shift it by 4 units upwards. So that is the impact of that c on a function. And also, if, for example, you want to draw a function of, let's say, a number being between 0 and 1. Let's say, for example, for 1 over 2 over there. I'm telling you, it is also going to take that shape. Let's quickly try to do a very quick sketch. It doesn't need to be 100%, but calculator, let's calculate. We have 1 over 2, open bracket, 1 over 2, you close to the power of, we start with -3. I hope I'm not losing you guys, to the power of -3 there. Can you see it starts at 8? That means we now have 8 there. Where it's -3, it's 8. Then you go and edit it. Let the -2, it gives us 4. So where is 4? 1, 2, 3, 4, -2 there. Then you go to -1, it gives you 2. There, -1, 2, it's somewhere there. Then you go to 0. Obviously, at 0, it is going to give you 1. This is 1. And then you do whatever negative. No, it's no longer negative, but it's +1. It gives you half. It gives you half. You can see it gives you everything that you had there. There, it might be -0,3, 0,1 there. Then it's just a matter of you connecting the dots. Can you guys see how nice this thing is? It's not really that much complicated, guys. You just need to be aware of all that I've explained to you guys. I'm telling you, when we solve exam type of question papers, you won't struggle. I'm not sure, guys. Are you guys following there? Does it make sense to everyone what I'm explaining there?
It makes it.
Noted from re Thabile, o thabile ko?
Yes, I can tell you.
100%. I see Kensani, he's raising his hand there. Sorry, Kensani, I forgot to unmute you because I remember you was trying to say something,
Sir,
but
is
your
this
mic was breaking. Kensi,
load
Kensi.
before?
Kensani, it's possibly you've got your mic on loudspeaker, or are you using headsets? If you're using headsets, try to
Okay,
maybe remove.
is this load shedding? That's why I did not have connection.
Oh, no, I see. So there's currently load shedding on your side, isn't it?
It's because
Okay. So, for Kenzani, I notice you're having a bit of a problem on your side. But remember, I think you are on gold package. So everything that I'm saying in this lesson, on our private lesson, we'll still go through all of this. Hopefully at that time, you won't be having load shedding. So when we do our private lessons, I'll still be taking you through all of this. And to all the new learners, remember, guys, whatever that you missed, it's not lost completely. This lesson is being recorded, and I'm going to post it on my YouTube channel. Then I'll share the link in the group. Then you can be able to catch up either tomorrow or sometime whenever you are free. Then you'll be able to follow when we solve exam type of questions the next day. So, I think now what I can try and do quickly is to do a bit of a revision on straight line, parabola, and hyperbola, just so that the new guys are all on the same page, so that tomorrow we try to solve exam type of questions. Are you guys ready, or is there someone who's got a question?
Anas, I'm good.
Okay. Anyone else to confirm? Seems like no question. Seems like no question from no one. Okay, so let me quickly try to do a revision on a straight line. So we said the general formula for a straight line, this is where it started at a baby stage. It started as y as equals to x. Then it grew to a teenage stage of y is equals to mx plus c. And then from there, as we said, it got to an adult stage, and this is how it looked like. So remember, we've got a Cartesian plane being a x and again y. So for this function of y is equals to x, it's just a straight line passing through the origin in that direction. But now, after some time, for example, let's say this is the graph of Mafranco. Bramafranco is our very good friend. So we call this the graph of f. We name it after Mafranco. So now, after some time, we realize that no. We've got something called the gradient. And the equation of the gradient we know is change in y over change in x, being y2 minus y1 over x2 minus x1. So we know that the gradient is actually the slope. So that means the slope can either be positive or negative. Here comes the question: what is the impact of the slope on a straight line? So for a straight line in the first and third quadrant, always the slope is positive. That means you'll always have a positive gradient. But for a line in that direction, in the second quadrant and the fourth quadrant, you will always have a negative gradient. So that means this could be a function of y, it is equals to negative mx, and that m, it could be maybe negative 2x or negative 7 or negative whatever. So for this one, it means it's y is equals to positive mx, or otherwise in terms of numbers it could be positive 3x, or any positive number. So remember guys, I've just explained now to say the C value is the given. It tells us about the vertical shift. What is the vertical shift? The vertical shift is that of up and down. So up is positive, down is negative. So if you have a function, for example, of y, it is equals to positive 2x, let's say plus 2. You need to be aware that this positive, it means your function will be in that direction. And this value of 2, it tells you of the steepness. If it's 2, let's say it's something like that. If it's a bigger number, then it gets steeper. If it's a bigger, steeper, bigger, biggest, something of that nature. But now, if the number gets smaller, then it is no longer in that direction. It's like it's no longer getting steep. It's getting less steep, less steep, less steep, less steep, until, for example, it's 1 there. Then it's at that slope, for example. The moment is a negative number, then you can see it is now in that direction. That is why we have positive, 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 until it is now negative, 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 whatever. So now when we have positive 2 over there, it means that same graph which was initially passing through the origin, it is now being shifted by 1, 2 units. Therefore, at the same slope, it is now passing through that. But if, for example, is that of y is equals to, let's say, negative 3x minus 4, that means the first thing we know is in that direction. But because of that negative 4, it means it shifted downwards by 1, 2, 3, 4. Therefore, it means it's now in that direction. That was a summary that I wanted you guys to be aware of regarding a straight line. I'm not sure if all of you got that. Did it make sense to everyone, ladies and gentlemen? So this is Monday. This is a summary of
Yes,
Monday's lesson.
Yes, sir.
Okay, 2 confirmed, 100%. So now, quickly, let me try to explain a summary of everything related to a parabola. So we said a parabola also, it started at a baby stage as y, it is equals to x squared. So this stages, guys, is more like a baby stage is in grade 10, teenage stage for parabola being this one. Obviously, you've got your a to the exponent of x. This is the teenage stage, which could be grade 11, otherwise in grade 10, it might also be there. In grade 11, it might also be there, that stage. Then we still have y, it's equals to, let's say, a x squared, and then we have plus c over there, which is an adult stage. But we said for a hyperbola, it goes up to Madala stage. So Madala stage is that stage that comes after an adult stage. And at Madala stage, this is how it looks like, as ax squared plus bx plus c. This is the Madala stage, and this is the only function that has Madala stage. So 3 years, we said a parabola has got only 2 shapes. Normally, it has got only 2 shapes. And the first shape is this one of a smiling shape, and that one of a set shape. I'll never get tired to draw this so that it makes sense that it's actually a smiling shape. And also indicate with this one that this is actually a sad shape. So you only have two types of a parabola. So let's try to check how do you know if your function is a smiling or a sad shape. That's where we talk about the a value there. So if a value it is positive, we've got a smiling shape. If the a value is negative, we've got a sad shape. So that means on your Cartesian plane, you are going to either have a smiling shape, which could be y it is equals to, let's say, positive 2x squared. Or otherwise, you could have a sad shape. A sad shape, which could possibly be, let's say, negative 3x squared. Very, very much important, ladies and gentlemen, over there. So again, this a value, I think it also tells us more about the opening of that. So it's more like if maybe it's 2 there, let's say it's like that. But if that number gets bigger, you might find that maybe the opening it's like that. Or maybe if it's smaller, like maybe 0.5 or maybe 1 over 2x squared, whatever, you might find that it gets narrower like that. Something like that. So you can draw different types of function on the same set of axes and try to compare. Same thing there, but obviously as negative values there. You can see it forms a very nice flower there. Okay, so now the moment we say, let's say plus 3, ladies and gentlemen, the moment maybe we say negative 2, we said the C value tells us more about the vertical shift. What is the vertical shift? Something can move upwards, and we know up is positive, or otherwise down, and we know down is negative, which means for this one it has shifted by 3 units up. So it's 1, 2, 3. So that means you are now going to be having your parabola drawn like that. Or otherwise, if it is shifted by what? Let's say what is it? Where is that other one? Let's say maybe by negative 4 downwards. So it is 1, 2, 3, 4. Then that means it is actually making a U-turn at negative 4 because they said it shifted downwards at negative 4. But remember, it makes a smiling shape if that it is actually what is it? Positive. So also if you want to sketch, you can say where x values, let's say it's negative 4, negative whatever, up to 0, then positive 4. Then you try to punch there the x values to see what are the corresponding y values, and then you start connecting the dots, then you plot. Also, there's another way in which you can plot, of which we'll do that when we solve exam type of questions. I think this is all that I wanted you guys to be aware of. But now, can you see the Madala stage? It has that B value over there, Kevin. What could possibly be the meaning or the impact of the B value? So the B value, it actually influences the sideways shift. So the moment you have a parabola at Madala stage, just know that it can shift. So it's more like, let's say this one, it shifts to the left. Then obviously, this is how you are going to draw it. It's going to look similar to that. Otherwise, if it shifts in that direction, it is going to be something similar to that. Or maybe if we shift this one to the left, it is going to make a U-turn in that quadrant there. If we shift it to the right, it is going to make what is it? A U-turn in that. Similarly, for a sad shape, if it shifts in that, or otherwise if it shifts in that, it is going to make whatever. Does it make sense to everyone, guys? Can you guys see that this will only make sense if you attended the lesson? But if you just see this without attending the lesson, it seems like it's complicated, but it is really not. Did it make sense to everyone?
Yes, I did. And I have a question, sir.
Yes.
Yes. Now I can clearly hear you, Kevin.
Yes, sir, Dad.
What's the point of order, honorable member?
Okay, sir. I wanted to ask that does B also affect the turning point? Hence,
Um,
can use that formula of x is equals to b divided by 2a. Is it possible for it to
Kevin, I couldn't hear the whole of your question, but I could pick up
you
something.
can
Obviously,
speak, sir?
let's see. So let's say we've got y, it is
Yes.
equals to negative b over 2a. So this is actually the y value for the turning point. So Gavin has got a point over there. So that means it's actually two things which have got an impact on the turning point of a parabola. So obviously we see the b value has got an influence on the turning point, and also the a value has got an influence on the turning point. So it's only the c value which doesn't have an influence. So that means this thing has got an influence. Also, this thing has got an influence on the turning point of a parabola. But in terms of what I've explained, is as it is, what Kevin is saying, we can add or top it up on top of what I've explained. You see, guys, the reason why I like master classes is because we also learn from other learners. Kevin, what you mentioned there is very, very much important, and thanks for that. It came as a question, but can you guys see that I've got something to add onto my notes?
Sir,
So that means
sir,
who's speaking? Someone has got a question. I had someone calling me there. Who was it? Was it you, Gavin? Mgavava? Hey, I think I had someone calling me, but it's fine. They'll call me again. So, can you guys see the B value and the A value? They also have an influence on the turning point of a parabola. Shravan, did you get it? Did you get that part?
Yes, sir.
So,
okay.
Order, honorable members, order. Honorable Kevin, given, take your seat. Martor, Mar, Mar, Martorell, Matavanga,
Sir,
you are
I
recognized.
was saying that it is supposed to be X, not Y.
Oh, yes, 100%. So this is the
It was
X
me, sir.
value is equals to
I was saying that
the
it's
whole
supposed
of
to be
that.
X is equals to minus B
Yes, 100%.
divided by 2A,
Yes,
not
100%. So
Y.
what Given is saying there, guys, is that this formula
It's
is
supposed to
actually
be
for the X
X,
value
not Y.
and not for the Y value. So let me only correct that part and say everything that I've explained, it remains as it is. And the reason to that is because when you use this formula to calculate the x value of the turning point, you will still use that same x value where you substituted the b and the a value to calculate the y value. So maybe given in answering your question, yes, the b and the a value has got an influence on your turning point, in a sense that you use the b value and the a value to calculate the x value of the turning point, and that same x value you are going to substitute it into that equation to calculate the y value. But in terms of me explaining, I think with what I've just said is just enough for you to understand the characteristics of a parabola. Because one thing for sure, because of the a value being positive, it is going to smile, and when it smiles, it is going to have a turning point, whether it's set or it's smiling or it shifts sideways or shifts up and down, it will always have the turning point. But in terms of me explaining, I might not have gone that deep, because you can see that the b and the a value, of course they do have an influence, but it's too deep. Can you see Gavin there? Does it make sense what I'm trying to explain there? I think someone wanted to say something. Martorell
Uh,
Matavanga.
yes, sir. Sir, sorry for joining the lesson yet, late. Sorry
Mhm.
also because I speak French. My English is not that fluent.
Oh
And
yes, I can also. You've got a very nice accent, Marto. Am I calling it correctly? Martorell Matavanga.
yes, sir. Yes, sir.
Martorell, I'm asking you to join my lessons on a daily basis. I think through you will learn French. How do I say how are you in French?
Comment ça va?
Comment ça va?
Comment ça va?
Comment ça va?
Yeah.
Hey, Martorell Matavanga, comment ça va?
Yeah, ça va bien, monsieur.
Hey, ça va bien. What's your point of order, honorable member?
Yeah, sir, like now I'm not getting anything because I came late, and my question
Oh,
is,
mm-hmm.
yeah, my question is if would you mind to upload this lesson by the end of the lesson?
So one thing for sure, Matavanga, this lesson I think is going to be over an hour long. But one thing for sure, tomorrow before 12 o'clock, our manager is going to upload this lesson. And again, it is not our first lesson on this. I will send you via inbox my previous lessons where I've done this lesson where I was actually. This is actually a repeat of everything that we did on Tuesday, I think. So I'll send you that link via inbox, and then tomorrow I'll also share this lesson in the group name.
Thank you, sir. I would like that.
Okay, and then again, in which grade are you?
Actually, I'm doing a bachelor.
Oh, okay, nice.
Yeah,
Bachelor.
this is my first year electrical engineering.
Oh, okay, no, I see.
Yeah,
So,
yeah.
so you just need additional lessons on mathematics.
Yeah, because where I came from, because I did all my class in my country, so where I came from, the things are quite different from here.
Oh, okay, okay. No, I see. No, I see.
Yeah.
Matavanga, through you, we need to learn French. So everyone in this lesson, guys, just make sure that you've got your notebooks there. For something like metavo, you write it down. When we greet each other, we just hammer a metaphor. How do you respond again, Martorero?
Respond for
Metaphor. Hey,
respond
metava.
for
Metava. What?
Matavanga.
Oh, no, no.
Matavanga.
No. How do I greet you? That responds to the greeting.
Oh, the greeting. Bonjour.
Oh, bonjour.
Yeah, bonjour. That is early in the morning. And in the
Oh,
evening is bonsoir.
bonsoir, bonjour, and bonsoir. Okay.
Yeah.
Guys, any questions before I move to what is it? I think it's a hyperbola that we are moving to. Do you guys have any questions?
Is there,
Mm-hmm.
please further explain the parabola in the standard form of y equal to a open brackets x plus p close the bracket squared plus q.
Okay. Lerato, I got that. Let me see. Let me remove all of this. So, Lerato, since this is Madala stage, what would you describe that one? That format that you've just given? Do you not want to give it a name, Lerato?
Sir, can I please name it?
Just hammer it given.
Legends. The legendary one.
Okay, so Lerato, let's maybe give that one a name to say as legend as it was given. So now, remember, the most important thing that you need to know is whether the function is smiling or if it's a said parabola. So what tells you if the function is smiling or it is whatever? This is what is going to tell you. If you've got a positive a value, already we know we've got a smiling shape. But if it's a negative value, we've got a sad shape. So now this part inside the brackets, it tells you the x value of your turning point. And then this one, it actually gives you the y value of your turning point. So when you have a function given in that format, they are actually giving you the turning points, and the values of your turning point is p and q. But remember that if, for example, you've got y being -2, let's say into x minus let's say 4 squared and then plus 2. This is how you interpret the legend. So you're going to say, since the a value is negative, that means you are going to have a sad shape. Can you see? You're going to have a sad shape. But now, this and that gives you the coordinates of the turning points. So now, what is the x value of the turning point? That means you equate this thing to 0 and solve for x. So you're having x minus 4, you equate it to 0 always. Then you transpose, therefore you've got x being equals to, it changes the sign, then it's positive 4. So that means for your turning points, you've got your x value being 4. This one, you take it as it is with its sign. Always. Therefore, you take it as positive 2. So that means your turning points, can you see? It's actually 4 and what is it? Positive 2. So your y cut or your y-intercept will always be less than. No, I made a mistake there. The turning point, the y value of the turning point is 2. So that means I might need to try to redraw this thing correctly. Let me draw something similar to that. Yes, something maybe similar to that. So the turning point, let's say the x value there, what is the x value? The x value is 4, and then the y value is 2. This is your turning point. I'm not sure why I keep on swapping those two. So what I was saying, Lerato, is that if your y value of the turning point is 2, that means your y cut will always be less than 2. You cannot have y cut which is above the turning point. So normally when you are given a parabola at a legend stage, it is always best to convert it to Madala stage, because it can easily be interpreted at Madala stage. So how do you do that? Obviously, you've got negative 2. Because of that squared, it means you have 2 of the same thing, being x minus 4, and then there you still have that plus 2. Then we're going to say this by that, that by that, this by that, that by that. So you are still going to have negative 2 into, as an example, let's say this is x squared. Let's say this is plus what? Plus 16x. Let's say, let's say, for example, is actually negative 8x, and this is plus 16, you close, you still have that plus 2 there. So you just simplify that inside. Therefore, because of this a value, you still say that by that, that by that, that by that. So you might end up having negative 2x squared, maybe plus, let's say, 16x, maybe negative 32, then you still have plus 2 there. So can you see you have negative 32 plus 2? Then you work it out, and then you end up having negative 30 there. So can you see I've converted it from the from this stage to that stage. That's if, for example, that's if it is necessary for you to convert it. But in some instances, depending on what the questions will be, you might not need to convert it to this stage, but just leave it as it is. Lerato, are you answered, honorable member, even though I was a bit quicker on that one?
Yes, and also sir,
Mm-hmm.
can convert it to this format by completing a square.
Let me see. I think because completing a square, it might not fall under master class. I think in metric, whoever was in metric and grade, grade 10, do you guys? No, I don't think they complete the square, right? Which means for that part, let's maybe put it aside for that day when we complete the squares, because otherwise the guys in grade 10 and 12, they'll be completely lost. I'm not sure if you get me on that one, Lerato.
Yes,
Okay. Matavanga, how do I say thank you? I want to say thank you in French to Lerato there. Bravo. Is it not bravo? Hey, Matavanga is watching Skim Sam there. Matavanga is watching Generations there.
Yes, sir. I can hear you.
So how do I say thank you in French, Matavanga?
Merci.
Merci.
Yeah, merci.
Merci. But what about bravo? Is it not French?
Bravo is like congratulations.
Oh, okay. No, I see. I think I'm going to have a tough time. You see, now I already forgot what thank you. What do you say thank you for the last time, Matavanga?
Merci, sir. Merci.
Merci, sir. Merci.
Yeah, merci.
Oh, Rato, merci. So, are we all on the same page, guys? Can I quickly move to the last part of the function being hyperbola? Then we know we are done for today's lesson. Shravan, Shreyas or Atile, are you guys doing good that side?
Yes.
Yes, sir.
Yes, sir.
Okay,
Sir.
100%.
Sir,
So quickly, someone has
sir,
got a
before
question.
you
Who's
remove,
speaking?
don't you?
Mm-hmm.
As I was saying that,
No, it's fine. I'll write it again. What's your point of order?
uh, I was saying that I think it's possible that you can complete the square. I
Oh yes.
think
Okay, no,
it's
I got it.
possible.
I got it. So, I'll just explain to what is it? I'll explain it to
I
all
was just saying that.
the new learners. So, Kensani, Matavanga, Oratile. I'm just not sure if Oratile is her first time. So, given I've got what we call masterclass. So what I'm doing today, it's called a masterclass. So in masterclass, I only do chapters common in all the grades. For example, if I'll be doing physical sciences, I won't do a chapter like what is it? I won't do a chapter like Doppler effect, because Doppler effect is only in grade 12. So I would do chapters like electricity, for example, because it's then grade 10, 11, and 12. So in this lesson, you've got 3 years in grade 10. You've got Lerato in grade, what is it, grade 11. You've got Lebogang, for example, in grade 12. So everyone in this lesson, you might be in different classes. Someone might be at varsity, some it could be other tutors or other educators from different schools. So I'm only doing chapters common in all grades. Then on our private lessons given, that's when I'll be taking you through a chapter of your choice, which is specifically for that grade that you are in. So the reason why I did not complete the square is because not everyone in their grades are completing their square. So that's why I won't be doing that one. So just be aware that from Monday to Friday, it's only chapters which are common in all the grades. Then on our private lessons, we can do any chapter depending on the grade in which you are. And also, depending on your package, you might be added to a classroom for grade 10, 11, or 12. If you are in those grades, towards exams, that's where I'll be streaming lessons in those groups, where I'll just be doing a lesson which is just dedicated to grade 10s, for example, or it's just a lesson for grade 11s where I complete the squares. But in this group that we are in, it's only master classes. I'm not sure. Did you understand the given? Did it make sense? Matavanga, I know it's your first time attending my lesson. Did you understand what I meant there? Oratile, did you get it?
Oh, yes, I did understand.
Yes, sir.
Okay, 100%. So, let me quickly go through a hyperbola very quick over there. Remember, guys, I've already done a lesson where I was, talking about hyperbola. So now, this is where the function for hyperbola started from. At a baby stage, as y is equals to a over x, and then over time we realized that actually this thing can be a over x plus p. Over some time, given Madala stage, we now have that plus that. Can you see the difference there? We just add q over a there. So now, this is what we said. We said if a value, it is positive, you have your hyperbola there in the first and the third quadrant. But if it is negative, you have it in the second and fourth quadrant. But most importantly, remember, we have what we call asymptotes. You remember me saying asymptotes for what is it? For the exponential. So for exponential, we only have one asymptote. But for a hyperbola, we've got two asymptotes. So at a baby stage, you have your asymptotes inside, ladies and gentlemen, inside your x axis and y axis. So the shortest way to explain this thing of asymptotes, it's actually to say this. Trias, if you've got in grade 10, if you've got a y being equals to, let's say 2 over x, just know that the original formula or a complete formula is this one that has a p and again that has a q over there. But in your case in grade 10, it is just going to be nothing there and there. It is just going to be, for example, 2 over x. But just know there's invisible p, there's invisible q there. So if it's invisible, it means your p value is 0. If q is invisible, it means it's 0. That is why when you draw a Cartesian plane, that p it is the x asymptote, and then this q, it is the y asymptote. So if it's 0, you can see the y asymptote is inside there, and then the vertical one, it is the x asymptote. It is actually cutting the x at 0 there. Then depending on your a, can you see it's positive, then it means you're going to have your thing there and also there. But if it was negative, it was going to be there and there, having your asymptotes inside. So that means this gives you the x asymptote and this gives you the y asymptote. So for example, in grade 12, let's say you've got y being equals to maybe negative 3 over x minus 2 plus 4. If the question says, what are the equations of your asymptotes? Remember, always for this one of x, you must equate it to 0, and then you solve for x being positive 2. But for this one, you take it as it is. So that means y, it is equals to, in that case, it is going to be equals to 4. Then before you can sketch this or that, you firstly start with this asymptotes. So where you see x being 2, you can do your vertical as, can you see, maybe 1, 2. So that means there, this is where you're going to have your asymptote. And then where y, it is 4, maybe 1, 2, 3, 4. There, that's where you've got what is it? Your asymptote. Then you look at a. Where's a? There's a. Can you see a is negative there? Then it means you're going to have it. This is first quadrant, third quadrant. Because it's negative, it's going to be in this quadrant and that quadrant. But you don't just do that. There's a way or process that you go through in order to sketch that. I'm not sure, guys, even though I was a bit faster because we did all of this last week, but were you guys able to grab something there? And do you not have some questions there?
No question.
Shravan, were you able to grab something there? Oratile, Lerato. Someone has got a question, guys. Or was it a yes? Was that a question from someone?
Sir, I was just saying yes.
Oh, okay.
I got
100%.
something.
Yes.
Lerato just said yes. So it seems like we are
Yes, sir.
all on the same page, guys. If that is the case, let me just quickly bring this question paper. I was doing this question paper with one of my learners, but it wasn't a master class. It was one of our private lessons. I just want to open your eyes to say, if you don't miss this kind of my lessons, you will never go wrong. Remember, these are the notes that I'm using for these lessons, guys. They are there posted in the library. Just make sure that you're in the library. You can just send an inbox to our manager there. She's going to help you to access this note. So question papers, for example, let me take it for grade 12, but you guys in grade 10 and 11, you will still understand this thing. Mathematics, that, this one. Okay. Can you guys see this? Can you guys see there? Is it not blurry? Are you guys able to see there?
Sir,
Yes,
it's a
sir, I can
little
see.
bit blurry. Can you please? Yeah, now I see.
I can see it so nice.
So is
Sir,
it
can you
everyone who can
please
see?
write? No, sir, can
Maybe
you
let me
please
write.
write the question?
Maybe let me write this. So I'll just write this. This is the equation. Then I'll write the question. So maybe if I do, let me see. Maybe if I do this, you guys can still be able. Can you guys still see now? Can you see now?
Yes.
Say it's
Yes, sir.
G. Now you can see.
Yes,
Ah,
sir.
yes, sir. We can see.
Okay, 100%. So let me quickly. Hey, someone stole my pen. Yay, Lerato, which guy pen at? Oh, hey. Okay, no, ngitholile. Okay,
Sir,
so.
can you please give us few minutes so we can try it? Maybe 2 minutes or
Oh,
3,
no,
so
no,
we
no,
can
no.
try it.
So this one, who is it? I see Kenzani, he's feeling the energy now. I see Given is feeling the energy now. But don't worry that much, Given. We're still going to do some more of these questions. So again, remember, it is there in the library, this question. So I won't really be solving everything. I'll just be explaining to you to say everything that I discussed in today's lesson, even though it was just a very quick summary for this type of a function. But everything that I've said, you can straight away solve this question paper of what is it? I think it was March for 2015. So for now, we won't be solving this question. It's just to browse through because it's almost over an hour that we spent for today's lesson. So it's just to brush through Given. But Given, you tell me, what type of a function is that?
It's a hyperbola, sir.
Did you say Ebola there? What did you say, Given? Ebola.
It's a hyperbola.
Hey.
Hyperbola.
Lerato, what is that? What do you call that? How do you pronounce that?
Hyperbola.
Shreyas, what is that? How do you pronounce it? Hey, Shreyas ran away.
Hyperbola.
Hyperbola. Marto, French.
Yes, sir. Hyperbola.
Is it me and Matavanga there who call it hyperbola? Because I call it hyperbola. But it's fine. Whichever way you pronounce it is fine. Hyperbola, whatever. But in good days, I call it hyperbola. So you guys are right. This is hyperbola at an adult stage. So can you see? Write down equations. Can you see the S there? equations of the asymptotes of G. So that S, it is very much important. It tells you that possibly you might need to give two values of asymptotes. And we do know very well that asymptotes on hyperbola, they are two. You've got the one for x and the y for y. And the one for x, you might need to solve for x. So can you see you've got x being equals to -2. That means there you give -2 there, and for y you take it exactly as it is. So let me not really try to solve everything there, but just explain to you what happens. So now 4.2 says calculate the y-intercept of G. Obviously y-intercept, that's where x is 0. Then what is it? You solve for y, and you do the same for x-intercepts. That's where y it's 0, then you put 0 there, and mathematically solve for x. I'm also going to show you that as we continue. So can you see, once you have the asymptotes, and then you have the x-intercept and the y-intercept, you can easily do your sketch. Obviously, let's say, for example, this is what? This is the Cartesian plane having the x and the y. So can you guys see that because the a value, it is positive, then it means you are most likely to be having your thing like that. Why? Because the a value, it is positive. But if the a value was maybe negative there, you are going to have your thing there and again there. I hope you guys you are able to see over there. Shravan, are you getting that part? Does it make sense?
Yes, sir.
4.4. Can you see what the question is saying? Determine, I almost say delete, I don't know what I'm thinking there. Determine the equation of the line of symmetry that has a negative gradient in the form of y is equals to that. This is something that I forgot to explain, guys. I have to add it to my notes. I'll just explain it now. So here they say determine the value or values of x for which this thing it is greater or equals to that. So you can only be able to easily answer this question after you've done your sketch correctly. So I won't go into that, but I'll just leave it for when we do this question paper. So can you guys see that almost everything that we discussed is actually there on that question paper, and you just score yourself 13 marks. But quickly, I want to explain something, guys. If we have a hyperbola, for example, let's say maybe, no, let me just do it there and say we've got a hyperbola, let's say there and there. When we talk about an axis of symmetry, it's actually a line passing through right in the middle, or that separates or that cuts these two functions into two equal halves. So it's more like if you do something like this, Mr. Gift, you connect there. This line, it cuts this thing into two equal halves, such that this side, it is exactly the same or equals to that. But now, tell me, are we having a positive gradient there or a negative gradient? Can someone tell me?
Sir, can you
Guys,
please repeat the question?
so this straight line, is it having a positive or a negative gradient?
It's a positive gradient.
Sir, it's positive.
100%. So that means there we are having a positive gradient. So that means the general equation for that one is y, it is equals to x plus c there. So that means this one is the one with a negative gradient, which is y it is equals to a negative x plus a c. So that means what is it? This straight line for a positive or for a negative gradient, it is actually passing through the intersection of these broken lines inside. So someone is asking themselves, what if it's not inside? So that means, for example, that one where we have x at -2 and then y at -1. Something similar to that. So this is the one on that question. If you remember, we had that axis of symmetry, I mean the asymptote at -2 and then that one at -1. And we said if we had to draw that, it was going to be in the first quadrant because the A value was +6 and then another one in there. So can you guys see that that line of, what is it, the axis of symmetry, it is going to be this line that is coursing through these dotted lines there. Can you guys see we already have y as equals to -x plus c? So you use this point, Lerato, where x is what? X is -2 and y is also -1. So you use this point to substitute it there and get the c value. Let's see. So that means you're going to have y is equals to -x plus c. What is y? Y is -1 is equals to negative, what is that? This is -2 plus c. Then this times that, it is actually positive. You take it to the other side, then you have -3, it's equals to c. So that means the equation that they want is y it is equals to -x minus 3. That's all that they, no, not for this line, but for this line, y is equals to -x minus 3. Even though I was quick, Shreyas, did you understand what I was trying to explain there? I'm still going to be explaining this when I solve for this question paper, but did you get my point there, Shreyas?
Yes, I understood, sir.
Lerato, did you get it? Oratile, Retabile, we told you lapho.
Yes, sir. So
Given Matavanga,
Yes, I
100%,
did.
sir.
100%.
Yes,
That's
I
what I
did
wanted to explain
understand it.
with regards to the line of symmetry. So that's what I was saying, guys. Even for straight line, parabola, exponential, easy. We're going to get full marks there. We're going to have a great time in solving those questions. So, guys, thanks very much for
Sir,
joining. A question given. What's your point of order,
sir,
honorable member?
uh, I was suggesting that maybe like finding the axis of symmetry, you can like on that equation
Yeah.
of G for X by
Mm.
taking the isotope of X and the isotopes of Y by saying minus bracket X plus 2 close bracket minus 1, then you can still get the same thing.
I think given, I want to try, maybe I can erase all of this so that everyone can also benefit from what you are saying there. So remember, guys, whatever that you say, whether be it correct or wrong, it helps because we don't know everything, and at your school you might be having a very useful information that is going to change our lives. Given, let's start it again, Mr. Isotope. What were you saying, Mr. Isotope?
I say we had that equation of G for X is equals to 6 divided by
Oh
X
yes.
plus 2 minus 1.
So the original equation was y is equals to 6 over x. What was this? Was it 2? Positive 2, nay? Minus 1 there, isn't it?
Yes.
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 I
So
like that
you
word,
can say,
isotope.
so you can say y is equals to minus bracket, no, bracket,
Mm-hmm.
x plus 2
X plus 2. Mm-hmm.
close bracket minus 1.
Yes. I'm not sure if someone realized something. Can you see that what given is doing there? It's more like he's saying this y, and then he's taking that and also that. But this negative, can you tell them, or should I tell them, given why that negative there?
You tell them, sir.
Yay! Okay, let me make you tell them. So, what did the question say? Did they say the axis of symmetry having a positive or a negative, whatever? Do you want to tell them a given?
No, sir, you tell them.
He's throwing me under the donkey cart. This one. Okay, it's fine. So this negative, ladies, remember we are having that and again that. So we drew that in those quadrants. So that means the axis of symmetry, it is that one having a negative gradient over there, ladies and gentlemen. So that is why in that position, this is the position of the gradient. Remember, it is going to be a negative gradient because of the axis of symmetry is having negative there. So this one, you also get the same answer because you just rearrange or rewrite this in the form of y is equals to whatever. So you always want to remove the brackets in maths. You always don't want to see the brackets. So it is that by that, that by that. What are you having? You have negative x, that by that is minus 2, minus 1. Therefore, it's y, it's equals to negative that. What is this? This is negative 3. I think this one is even easier and quicker than the one that I've showed you guys because you just work with whatever that you are given from the formula. Am I correct in saying that Mgavava, Mr. Isotope?
Yes, sir, you are very much correct.
Mgavava, what is isotope? Can you explain to everyone what is isotope? Because I know Lerato is thinking about ice cream there when they hear isotope. Can you tell them we're not talking about ice cube there, Kensani?
Don't involve me, sir. Don't.
Matavanga, are you not thinking about ice cubes there?
No idea, sir.
Okay, but what I've just discovered, this could be the easiest way. Lerato, Shravan, Shriyas, are you getting what Kensani is saying there?
I said they are watching the Queen. That's
Ah,
Hi,
okay.
Camille, I
So
don't get you given. Please, furthermore
okay,
explain.
so Lerato, what given is saying, given will just tell if I'm wrong or correct. So what given is saying is that if the question says, maybe give an equation of axis of symmetry eh, that has a negative gradient, for example, you just say y is equals to y is equals to. Then because of it has a negative gradient, then you put negative there. Then inside the brackets, you just take it as it is, which is x minus 4. And then you just take it as it is. which is what? Plus 3 over there. Then you just solve that by that, that by that. You have negative x, positive 4, and then you still have plus 3 there. Then it ends up being y is equals to negative x plus 7. Then this is the equation of a axis of symmetry having a negative gradient. So if it had a negative gradient, maybe there it could have had negative 2. So that means you're just going to have y is equals 2, then it's just positive into x minus 4 plus 3 there. Then you just solve. Otherwise, if you are given, let's say, f of x being equals to, let's say, negative 4 over x minus 3, let's say, minus 1, then it means you would say y, if they want it having a positive gradient, then it's just positive into 3, x minus that, then you just simplify and write it in the form of y is equals to mx plus c. Given, do you put a stamp on that one, or do you have an objection to that?
No objections, sir. No objections.
Thanks, Your Honor. Lerato, you get it? If you don't get it,
Now it's clear, sir.
Matavanga is confirmed. So remember, guys, this thing, Shriyas, you might not need to worry that much about it at your stage. I'm just not sure about Shravan if you're having an idea of what we're doing over there. But remember, guys, this is not our last time doing that. We are still going to do it when we solve for question papers. But before I close the lesson, Shravan, did you have an idea there? Oratile?
Yes, sir. Yes, sir.
Okay. Retabile, are you happy there? I assume Oratile is on the same page as us. For today's lesson, I'm going to ask Matavanga to close our lesson in French. All that he has to say is that thanks very much for joining. I hope you enjoyed as much as I did. My name is Desmond, and I'm out. Matavanga, can you go for it?
Yes, sir. With pleasure.
3, 2, 1.
Merci beaucoup pour être ici. Alors, c'était vraiment une leçon très très bien et nous tous on était en train de profiter de ça et le professeur il est très très intelligent et on se voit seulement demain à partir de 19h30. Merci beaucoup.
Merci beaucoup. Ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it is massively, massively, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please do allow me to say, make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen. Ladies and gentlemen, have a very good night. Cheers, guys.
Thank you, sir.
Thank you, sir.